welcome everyone. Welcome to the course of programming in Python. In today's class, we are going to focus on the topic called as operators. So let's get started. So I'm sure all in the preceding classes you have learned what are the different data types, what are the different data structures to hold and access the data. And in this session, we are going to cover and focus on the operators. So these, what you see on the screen, arithmetic, comparison, logical, membership, assignment, and identity. These are basically your operators. Uh, Before we delve deeply into individual topics, let's first learn what an operator is. Basically, an operator is any special symbol, or you can say any symbol or a keyword which has a special meaning to Python. For example, uh, if I write here temperature equal to 22, or if I write here climate is equal to monsoon, right? What am I doing here? I am storing 22 value in the variable temperature, and here I am storing the string value in the variable climate. But how does Python know that what is on the right side it needs to store in this variable? It knows because of this symbol, this equal sign. So it's an operator. It's a symbol which has a special meaning to Python. So this is actually conveying to Python that whatever is on the right side, please store here. And just like this symbol, we have a lot many symbols categorized into different categories, as you can see here, for better classification. So let's first learn what an arithmetic operator is. As you can see here, let me start by creating two variables. So I'm storing 11 in x and 2 in y. And these symbols which you see here, plus, minus, multiplication, division, these symbols has special meanings to Python. It means whenever I am going to use this particular symbol, the data on the left hand side and on the right hand side is going to add it up. Python is going to add them. For example, you can see here, print 5 plus 6. If I try to execute this or run this, you will see that the answer is 11. In the same way, if I do minus here, you're going to see 5 minus 6, that's a negative 1. You see, negative 1. So these symbols must be very familiar that they do the basic mathematical operations, plus, minus, multiplication, division. But let's try to understand what a floor division is, what a modulus is, what an exponential is. Basically, this is a symbol of floor division. What floor division does is, whatever answer you're getting, if it's a decimal, then it is not going to consider your decimal part. Remember, it is not rounding off. It simply means that it is not going to consider your decimal part. It is only going to consider your integer part. Okay, so whether it's 5.1 or 5.9, you are only going to get the answer as 5. Now let me try to run this and see. You see here, I am getting the answer as 5. Got it? So that's the floor division. If you have anything a little more than an integer, you are getting something in decimal, then the decimal will not be considered. You are floored to the lower integer value. Okay. Yes. Now let's see what a modulus is. Basically, if you ever had done the division, something like this, if I'm trying to divide 2 by say 10, you can say that 2 5 times is 10, right? So there is no remainder because it's completely gets perfectly divided, so there is no remainder. This is what the modulus operator gives. It always gives you the remainder. If I'm dividing 2, say if I'm dividing 11 by 2, in this case I can write here 5, so 2 5 times is 10, and here its remainder is 1, right? So this is going to be my answer. Let's see here. Let me write here print, say 10 modulus 2. What's going to happen is you get the answer as 0. But if I'm doing 11 modulus 2, you're going to get answer as 1. Why? Because modulus sign always gives you the remainder, okay? And that's why you're getting this answer. Now let's see what an exponential is. I'm pretty sure that in your mathematics high school, you would be writing something like this: 2 raised to the power of 3, 6 raised to power of 5, isn't it? This is how you used to write, right? So the exponential is nothing but it's an operator given to us to do such kind of calculation. So if I'm writing, yep, here you can see that I am utilizing the exponential operator here. X, now this is as good as x raised to the power of y, and the answer you get is 121. So when I write like this, it is something similar to writing x to the power of y. All right, this is what it is. So basically, arithmetic operators helps you to do the arithmetic computations or calculations on the numeric kind of data. But when it comes to other operators, so let's move on to what is comparison operator. Before I tell you in Python what a comparison operator is, let's try to correlate with our daily life. So every day before taking a decision, you would always do some comparison, isn't it? For example, you will look at a watch. Is it less than 8 p.m.? Then it's good time to go out for shopping. But if it's greater than 10 p.m., then you would say, oh, it's too late, I won't go out. So what did you just do? You basically took a decision based on some result which came by comparing the data. You compare whether the time is less or time is greater than, right? So even in Python, you have certain symbols which help you do the comparison, and based on those comparisons result, you arrive at certain decisions. So the decision making is the next topic we are going to learn shortly later, but let's see what the comparison operators are, okay? So as you can see on my screen, please do not focus here, just see that I'm just creating two variables, and you are just supposed to know that you have certain symbols like less than or greater than. No, oh sorry, this is less than or greater than or less than equal to or greater than equal to or equal to or not equal to. Basically, if I'm writing print x this symbol and y, then it is something like I am asking Python and I am making or I am making a statement that x is less than y. So you always read it from left to right. X is less than y. Is it true? Let's look at it. X is 11 and y is 2. So x 11 is less than 2. It's false. So if I run this, remember, whenever I do any comparison, the result or the response of Python is always going to be either true or false, because we are doing a comparison, right? The comparison is either going to be true or it's false. So if I run this, let's see what's the response of Python. It says false, obviously. But if I change the symbol here and try to run it again, you shall see that it's true, right? So what we just saw is we in the previous example you saw that I was trying to compare if x is less than y, and now I'm comparing x is greater than y. Just like less than greater than, you have greater than or equal to, less than or equal to, is it equal to or not equal to, okay? So any data you can compare. Now even whether it is say 5 equal to 6. So what I'm trying to say is 5 is equals to the value is equal to 6. It's false. If I run this, you get that is false. But if I write 5 equal to 5, you're going to get that as true, right? not just the integers, but you can also compare the string. For example, I can write Arun, it's equal to Arun. Can try to guess what the response could be. Is it true or is it false? Well, you might say that Arun and Arun are same, but no. Python is case sensitive. When I say case sensitive, the capital A and small a are not same. So this is going to be false. Let me run it. You see, it's false. But the moment I make it capital A, you're going to see that it says true, right? Yep. Just like this, if I put this symbol, it would say that Arun not equal to Arun. But both are same. So this is like, this condition is going to be false because I am saying Arun not equal to Arun, but that is a false thing because they are equal, right? So that's how you utilize the operators or these symbols to tell Python or to convey my Python that it has a special meaning. And what special meaning? That I am trying to compare what is on the right side. I'm making a statement that what is on the right side and what is on the left side, they're not equal, but they are equal. And that's why, according to your comparison, you're either gonna get true as a response or false as a response. Okay. So please look here carefully. What symbols do we have? We have greater than, less than, greater than or equal to, less than or equal to, and like this. Okay. Right. Now let's look at now I'm bringing your focus towards the another topic that is called as logical operators. Okay. Before I get into what is logical operators, please try to know that on day-to-day basis, it's not just one decision that you take. Sometimes, for you to take a decision, you might you might rely or you might depend upon many other smaller decisions, right? For example, on Sunday, if I have to go out and play, then it should be weekend and it should be sunny, right? So here, if you say, I'm just taking a decision that whether I should play or I should not play, but it depends upon two conditions. One is it should be sunny and it should be weekend. So if you observe here that I am required to have both the conditions true. It has to be sunny and it has to be weekend. Only then my overall condition becomes true and I will go out and step out, right? So this particular keyword will help you to establish multiple conditions. For example, if I write print 5 less than 10, that's correct, and 2 less than 3, this is also correct. So if I run this, you shall see that it's true, right? Why is it true? Because the and symbol or the and keywords, it actually conveys that what is on the left comparison and the right comparison or the condition, they should be true, right? Together, and only then the overall condition shall be treated as true. You can see here. But if I make even one as false, for example, if I make it 15, 15 less than 10, if I try to run this, it says false, right? Perfect. So, and mandates the conditions or the comparisons surrounding it, have everything has to be true. But or, when I am going to use or, in that case, either the left or the right, if either of them becomes true, the whole conditions is going to be true for you. For example, give a quick look at this particular example here. I have created two variables, one is score and one is attendance. So these variables are of the students. So what's the score of students and what the score of his attendance? What's his attendance percentage in the whole academic year? And what I'm doing here is, don't worry about what is his if and what is his else. These are just some decision making keywords. You haven't learned as of yet, but going forward you'll learn. Just focus on this particular condition. I'm using OR. That means either your score is greater than 33 or your attendance is greater than 75. Either of them is true, then you are going to get eligible to sit in an exam. Otherwise, you cannot sit for the exam, right? That's simple. So, using or and, you can establish multiple conditions. And why would you need to write conditions or comparison in code? Because based on that is only what you're going to take the decisions. All right, perfect. So that was all about comparison operators. So far we have covered three of them. What is arithmetic? So arithmetic are the symbols like plus, minus, multiplication, exponential, or modulus, which helps you do the arithmetic operation on the data. The comparison operator, the less than, the greater than or equal to, not equal to, is it equal to, all such symbols are going to help you to compare the data. Okay, and logical operators. So basically, the logical operators help you connect multiple conditions, and together you can take the decisions. Okay, all right. Now let's see what is a membership operators is. So in logic, in the logical operators, you just learned and, or, and not. Okay, I think I haven't discussed not yet, right? So just like in and, basically you're mandating everything has to be true in or, either of the condition has to be true. But what about not? Not basically reverses your result. So for example, if I'm trying to compare here, print 5 less than 20 is true, obviously, right? So it says true. But if I push it into not, that means I am reversing the condition. So whatever the result will be, it shall be inverted, or it shall be made opposite. So if it's true, it's going to become false. If it's false, it's going to become true. If I run this, you see it becomes false. But if I make this condition as false, then since this is false and I'm putting it in not, you see the decision has been reverted. I mean inverted, right? So that's what happens here. All right. So that's what about the logical operators. Now let's look at the membership operators. Please remember that just like in logic you have or and same way in membership you have in and not in. At the moment, if you're finding it difficult to return, don't remember. Don't worry. Going forward, all this will become uh, a part of your day-to-day coding, and it will be ingrained in your muscle memory. So let's try to understand what a membership operator is. In membership operators, these keywords help you establish a condition where you're checking whether a part of data is a part of larger data. For example, if I write, oh well, I'm not really not sure about this example if it's correct, but let's see. If you see here, I have a larger data, which is Africa has the largest number of countries it's storing data, and then there is a substring. A smaller word is stored here, right? So if I check print, if substring in data, what basically I'm checking is whether what is stored here, that means largest, is it a part of data, is it present in data? So if it's present, obviously the largest is present here, it's going to tell you yes, true. So you get true. But if I say mm, highest, okay, so I am looking if highest in data, I'm making a statement that highest is present in data, that's false, right? So immediately it's going to become false. Got it? It is not necessary that you have to store it in a variable and then you have to check. You can also put the data directly here and you're checking that the data is part of this. And when I say not in, that means you are making a statement that highest is not present in data. Of course it's not present, then it's going to give you true. Yeah. So this is how the membership operators works. It's in and not in. Okay. Now what is assignment operator? Let's learn what is assignment operators. This is quite easy and I'm pretty sure that you have already been using it. For example, when I say count is equal to 50, you see you're using the equal sign already. So basically what's happening here is this symbol is called as assignment operator, it's equal sign, because it conveys Python that what is on the right side should be stored here. Now let's learn what are the other types of assignment operator. Okay, suppose if count is equal to 50 and if I'm writing here count equal to count plus 1. So since Python comes from top to bottom, after looking at it, what it is supposed to do is it is going to create a variable called as count and it's going to store 50 in it. But if you see here, it says whatever is stored in count, add 1 to it and the resultant result should be stored back in count, right? So if I try to print, you will see that it says 51, right? So basically what you're doing the addition operator and then you are assigning it back, right? The same thing, can be written in a different format like count plus equals to 1. What this means is whatever is on the right side should be added with respect to the right hand side and then the collective result should be exposed to this equal sign, which means the collective result should come back to count, right? So this is how the count works, or you can say the assignment operator works. So just like you did for plus and equal to, in the same way you have something called as minus and equal to, you have something called as multiplication and equal to, you have something called as divide and equal to, and you have exponential and equal to. All means the same, that first do the subtraction what is on the left side with respect to the right side and then do the assignment. That means you assign it back also. So that's the assignment operator. Otherwise the most common thing that you can remember is this equal sign. All right. Okay, now let's see what the pending operators are. One is, and then there is something called identity operators. Okay. I think the identity operator is nothing but there is a single keyword that is called as is. So you just check that if I'm creating x equals to 5 and y equals to 10, is only checks if it's pointing to the same location. So x is y. Obviously they are two different variables and they have a different memory addresses in your laptop. Okay, it's giving an error. Perhaps my mistake. I shouldn't have kept this. You cannot have such standard. But okay, now the code is clean. It says false. That means obviously the x is not y because both are different. And if I write is not, that's going to say true. So basically either when you say identity operators, what you are confirming with Python is when you check with respect to is, or not is, then what it says is that you basically are checking if the two variables are same, pointing at the same location, or it's not pointing at the different location. Okay, that's the identity operators. Not so commonly used, but good to know. The most commonly used and the important operators are arithmetic and comparison and logical. These basically run the whole show. Okay, and of course the membership also. Membership just checks whether the data that you're checking, is it a part of a larger string, or the data, is it a part of another list, etc. Okay, right. For now, these are enough. There is something called bitwise operators also, but it's not right time to take that up. Perhaps after some more sessions, I'll be uh, exposing you guys with the last remaining that bitwise operators later on. Yeah. Okay. So that was all about operators. So operators are the special symbol which has a special meaning. They're going to convey Python something, and your operators are categorized different. You have arithmetic, comparison, logical, membership, assignment. So arithmetic is nothing but the plus, minus, etc. The mathematics one. Comparison helps you to do the comparisons. Logical helps you to connect multiple conditions. Membership checks if the smaller data is part of the larger data. Assignment operator is nothing but the assigning the values, and identity is nothing but you're checking whether the both are variables are same. Okay, so thank you guys. That was all about the operators as a concept in Python.